Okay, so today we are going to learn about Venn diagrams. Before we learn about the Venn diagrams, we will try to understand about sets. So sets are groups. So you can think about this. So this is a set. Now you can say it's A. So you can have elements here. 1, 2, 3, 4, 5, something like that. So you can say A is nothing but, so curly braces, 1, 2, 3, 4, 5. Now, if you use n of A means number of items in A. So answer is 5, number of items in A. Then, think about that we have another set inside this. So that set looks like this. This is the set. We will name that set to be B. So B is nothing but 2, 3, 5. So n of B is 3. Now we can see obviously B is a subset of A. So B is a subset of A. So how do we write this in math notation? B is a subset. This is the notation for subset of A. So B is a subset of A. And then we can say 2 is an element of B. So how do we write that one? We write that one as 2 is an element like this. This is the symbol of B. 2 is an element of B. Then we can extend this further. So you can say 2 is an element of B and 2 is an element of A. This also works. So this is how sets work. So B is a subset of A. So it's a set inside a set. And A can be considered as a universal set, the most outer set. And the elements are inside. So elements can be categorized the way I showed it to you. And the number of elements inside is defined as n of A, n of B. And we try to get the count of that. And we need to understand this notation, element notation. This is the element notation and this is the subset notation. Now let's talk about the Venn diagram. The Venn diagram looks like this. The most outer set is called E, universal set we call it. So this is called universal set. So A and B are subsets now. So you can say A is a subset of universal. I would say it's E. B is a subset of universal. So that can be done. Now let's think about a few elements inside. So 1, 2, 3, 4, 5, and 6 outside. So what are the things you have in A? So if you look into this, it's going to be 1, 2, 3, and 4. And n of A is going to be 4. You can see 4 elements inside. And then B is going to be 3, 4, and 5. 3, 4, and 5. And n of B is going to be 3. So those are the things we can find here. And what about the universal set? So there you get 1, 2, 3, 4, 5, 6, everything inside. And then n of E is going to be 6. Okay. Now we'll try to understand, if you want to isolate this part, how do you isolate this part? If you want to isolate just this part, how to do that? And what about this part? How to do that? And what about this part, the outside, which is just that 6? How do you do that? So we will try to understand that. Okay, so now we will try to understand complement of a set. So set A is what you can see in the green color island, the one which I'm showing you. So this is A. So if that is A, the complement of A is written as A prime or sometimes AC. So that would be the outside one, the reddish color one, AC or A prime, I would say A prime. So that's the complement. So that's all about it. So complement is not A, not in A. So that's all about the complement. Okay, so now let's try to understand. Suppose this is A and suppose this is B. Let's try to understand how do you catch this one? How do you catch this area? Right? So this area you can catch through this A intersection B prime. Intersection means common, which I will teach you in a minute. Then this is A and this is B. So this you can write as A prime intersection B. Intersection means common. I will show it to you in a different diagram. So what about this common area? So that can be written as A intersection B. A intersection B means things common between A and B. Okay. Okay, now let's think about this. I'm going to shade A. So this is A. Then I'm going to shade B, which is this guy, like this. So now you can see this area. You can see this area. So this is going to be B. This is common. You can see the shading part. So this is common to A and B. And that is defined as A intersection B. That is the intersection part, common. Now let's think about this one. So I'm going to shade B prime. So what is B prime now? B prime means not B. So B prime can be everything like this, right? Not B, everything like this. Everything not in B, outside. Like that. Now, I'm going to draw, let's say, A. So A I'm going to color. A I'm going to color. Now you can see this part. You can see this part now, the black part which I am showing you now. That part is common. You can see the shading, common. So how do you find that one? So that is B prime intersection. Common means intersection. What we have shaded is A. Okay. So this is how you find that region. So that is what I was showing you here. That is what I was showing you here. So similarly, you can understand how to get this one. This common part I already shown to you. Okay, let's think about what we have learned so far. Summary. We understood what is A prime. A prime means not in A. Then we understood what is intersection. Intersection means common. Now we will understand what is union. Union means total. Total without duplicates. without duplicates. So why I put this duplicate term? Because sometimes we double count, so we have to stop this double counting. Okay, so we'll try to understand union part. Suppose this set is A, the other set is B. Then A union B means A union B means A including B. So all of these things, that's A union B. Right? So before we understood that this part is A intersection B, this part is A intersection B prime, and this part is A prime intersection B. Now the shaded part is A union B. So now you can understand logically A union B is nothing but A intersection B prime plus the middle island A intersection B plus A prime intersection B. So you can have this relation intuitively if you want to understand how this union works. Okay, so now let's think about this. This is going to be A intersection B prime. This is A intersection B. I'm going to write it in small letters. So this is going to be A prime intersection B. So this is what we understood, and that whole thing is called A union B. Now what about outside? Outside is nothing but A intersection A prime intersection B prime. A prime intersection B prime. So that is the most outer. So if you want to visualize it, you can shade it like this and then see which one we are talking about. So this is cool. The reason is all sections are written in terms of intersection. And this one itself is the union. This one itself is a union, A union B. So A union B you can write in terms of intersections. That's what we understood. The outside of the set can be written as A prime intersection B prime. Okay, so now we will try to understand how to find the probability. Okay, so consider A intersection B prime. So that would be this part. Now you can find, okay, if you do that, you write in this way, you get the elements here. You write down the elements here, comma, second element, comma, third element, like that. But if you say n of A intersection B prime, there you get the number of items inside. That's it. Then if you want to find the probability of A intersection B prime, how do you do that? So this is going to be n of A intersection B prime divided by the total number of items. Total number of items. That's how the probability is defined. The total number of items can be written as n of universal. So n of A intersection B prime divided by n of universal is the probability of A intersection B prime. Similarly, you can write probability A intersection B is n of A intersection B divided by n of E, and probability A prime intersection B prime, this can be written as n of A prime intersection B prime divided by n of E. So always the denominator is the total number of items, and that is n of E. Importantly, we'll think about what is probability of universal. So probability of universal is n of universal divided by n of universal. That's going to be 1. So probability of universal is 1. So that means that's total probability. So if you think about probability, values, these values can change between 0 and 1 only. You can't exceed 1, you can't go below 0. So you can understand that from here. Let's think about an example. Think about an example. What is 1 minus probability A prime intersection B prime? Okay, let's try to understand this one. Okay, so A prime intersection B prime is the outside, right? So 1 means the total probability. So 1 minus the outside means we are talking about the inside. We are talking about the inside. So if you want, you can say this is nothing but probability A union B. So that's the right answer. Or you can say this is nothing but probability of A plus probability of B minus probability of A intersection B. Why minus probability of A intersection B? So you are removing the double count, right? So this is to remove the duplicate. Okay, so now we'll understand how this duplicate works and how to remove it, right? So probability of A means this. So carefully we have to look into this. Now you can see this intersection, which is A intersection B, is already counted. Then I'm going to take B. So I'm going to take B in this way. So now when I take B, again I have shaded A intersection B. So now you can see I have counted twice, right? So, but when you are taking probability of A, add to probability of B, right? So this is what mainly we did. Probability of A means this whole thing, and then adding to probability of B, which is this whole thing. Now you can see double count here, right? So we are going to remove one of the count. So when you remove one of the count, so if you think about the reddish part, right? If you think about the reddish part, this reddish shaded part, that is removed. So if I remove that one, what you are going to have is just the blue shades here. Okay, I hope you understand. So finally, what we understood, probability of A intersection A union B is equal to probability of A plus probability of B minus probability of A intersection B, right? And that is what we discussed in this example as well, right? So now you can go back to this example and understand why I removed it, okay, from here. So that's the end of this lesson. Thanks.